What's going on YouTube? Today I have a really exciting video. So we are actually going to be building a Tesla coil. And I have been into the whole electrical engineering thing for the past few months, so that kind of reflects here. But this is a project I've always wanted to do since I was a kid. I thought they were so cool. And finally I've studied enough to actually be able to make one. It's kind of on a budget, so we might have to sacrifice some stuff and it could be upgraded later. But the layout is basically going to be a flyback transformer for the power supply unit. We're going to try that. If it doesn't work, we're going to swap it out with a neon sign transformer. I already have the flyback circuit made, but the next part is really going to be all the mechanical intricacies of the Tesla coil. So I've got most of the stuff here today that I've gotten for Lowe's. The other half really is going to come tomorrow from Amazon, and that's when we're really going to get kicked off here. But I decided, why not do a little video of the build. This isn't a tutorial because there is so much complexity that goes into creating a Tesla coil. There's so many different measurements and different ways you can do it. So in no way is this going to be a tutorial unless you already know all those mathematics and you're just looking at the construction. I'm purely making this video just to construct it on YouTube to show you guys what I've been into lately, and I'm really excited for this. If you're watching this video as it comes out, I'll see you in the comments, in the chat. I'll be here chatting with you. Anyways, let's go and get into the video. I'm going to go ahead and start trying to build this thing. If you like my content, please make sure you hit the thumbs up button. Make sure you hit the subscribe button. And if you are interested in this, or if you have any questions about the Tesla coil build, or how I found it, or what I did, or a specific material, make sure that you comment down below and just go ahead and ask. Or if you want to see something else built, something along the lines of this, make sure you go in the comments and let me know down below. Anyways, let's go ahead and get into this. After all the cutting was done, this is pretty much what I got from Lowe's to start working with. I'm going to be using Leyden jars as the capacitor, so this is going to be the aluminum foil to create my Leyden jars. I have 50 feet of copper coil. Hello. I have 2 wooden plates here, which is going to be the stand and the base. This PVC pipe here is going to be obviously for the secondary coil. And these right here are different stands and holders for the copper pipe to make sure we get that strung up okay. And so we're going to go ahead and throw together what we have here and see how it looks. How the frame's going to work. And I'm going to take this copper wire here and I'm just going to drill holes in these and spiral it around. That way it keeps it in order. This is a 1/4 inch copper pipe, and they need to be 1/4 inch apart. So I'm going to go ahead and just make the markings on the wood and drill the holes, and hopefully it'll be nice and easy stringing the copper wire through, or the copper pipe. But I doubt it. There we have it. Started out from 1 inch. So at this point, I'm going to go ahead and label this board. And it is safe to go ahead and start drilling holes in these. It's about the worst drilling job I've ever seen. But one down, it's quite a mess. And we still have 3 more to go. Alright, so I think my drill died on me. So now I'm going to go ahead and get the actual primary coil ready, or at least the PVC pipe. So what we're going to do is just clean this off real good, make sure it's really clean, and then we're going to put a coat or 2 of a varnish on it to kind of coat it and seal it from just some electrical insulation, more so than what it already has, and add maybe a little bit of grip to it for when we do get our magnet wire for a primary coil. So I'm going to go ahead and get this cleaned up with some alcohol, and we'll go ahead and get it painted. For the first coat on the PVC pipe, we're going to put a coat of polyurethane. After we get the second coil wound, we're also going to put 2 or 3 more coats of this on top of that for further insulation. So I'm just going to go ahead and douse the PVC pipe here in this varnish. Alright, so we're just going to coat this. I thought it was going to be a little thicker than what it is, but that's okay. We're just going to coat this PVC pipe in at least 1 layer of this. And I'll use this stand right here to try to prevent any type of mess from happening. Just for some extra insulation. As we let this dry, it is a little stinky. As we let this dry and the battery charge, I'll go ahead and plan out the next steps and see what we need to do next. Alright, so after a partial mental breakdown, I realized that maybe running a copper pipe through those holes is not such a good idea. So I turned online, and of course, why didn't I think of it before? Why don't we just 3D print some supports? So as of right now, the 3D printer is warming up. And we're going to 3D print our primary coil support, and we're just going to super glue the thing onto the wood, and it should be a perfect imprint. So yeah, it's going to take a few days. Unfortunately, it's going to take a little longer to put together because 3D printer is going to be the holdup, but that'll give me time to wind my secondary coil over the weekend. Alright, so I'm currently printing the base of my primary coil holder, and for the most part it's turning out okay. We did have a little blip over here, but so far it's looking pretty good, and I'm really glad I found this. Day 2, the printer's still printing, and we just got a fresh shipment of almost everything else that we need to get this thing built. The only thing we're missing is the magnet wire for the second primary, or the second coil from eBay. So now what we're going to go ahead and do is go ahead and make our capacitors. So I mentioned that we're using Leyden jar capacitors. These are pretty much homemade capacitors, usually used with glass bottles, plastic bottles, or some type of aluminum foil or salt water, or the mix. We need exactly 8.6 nanofarads capacitance enabled in order to get this thing resonant. So I've already computed that I need about 5 jars of this, as each of them are around 1.7 to 1.8. So I'm going to go ahead and just start making some capacitors. So I'm just going to cut out these, line it with aluminum foil, we'll fill it with salt water, get the screw in the top, and it's going to look real good. And there we have it, the Leyden jar capacitor. So now we just need to make 5 more of these guys and put these in parallel to combine their capacitance. Alright, so our capacitor bank is almost finished. I just measured the capacitance. It's only at 5 nanofarads. We need 3 more. We'll come back to this and add it pretty much at the end of the circuit. But now we're going to go ahead and start rolling our secondary coil. So now we're going to wind our secondary coil. And basically this is the part that's going to be the hardest, because I have 24 gauge magnet wire, and I need to wound about 22 inches on this PVC pipe, close knit, very tight, so it doesn't come unwound. And I have to do it about 1,000 times. So this is probably going to take a few hours, so I'll see you probably halfway through. Alright, so it's about 3 a.m. and I finally finished the coil on the secondary. It didn't turn out perfect, but it's definitely a labor of love. My fingers are sore. It was pretty rough. So this is how the coil itself turned out. And now we're just going to go ahead and put a coat of polyurethane on it. The first coat of many. Alright, I know it's a little noisy out here, so I'll keep this short. I've already put 2 coatings on this. I'm aiming for at least 3. I found that the paintbrush always dries out. Probably doing something wrong, so I'm using a rag to get maximum coating on this. But we're going to go ahead and just slap another coat on here. The more the merrier. You know, you can't hurt, because the more insulation you have, the better chance of success you're going to have. So we're going to go ahead and throw another coat on this one. I've already kind of played with some different ways that we could do this, but the best thing I could come up with is taking a aluminum dryer duct and sandwiching it between 2 pie pans, kind of like this. And so I've already kind of cut out what I hope to be the right measurement for this. So what we're going to do now is actually start getting these pie pans together. So the goal is going to be put this on top and kind of stretch it around the bottom one, put the top one here, and then use zip ties, because I don't want anything metal, to start pulling these pie pans together and see if I can't get them lodged in between. Alright, so I have my zip ties in between the pans. I don't know if this is going to be a good plan or not, because something could rip, something could bend instead of doing what we need it to do. But I'm going to go ahead and tighten these things down and just hope for the best. My idea was to have 2 pie pans and sandwich them so hard together that they collapse in on each other, but that didn't work. Alright, so my wonderful wife came in to save the day, and we just had Indian cuisine, and it came with a smaller foil pan, and I think that's going to work a lot better actually. Hopefully, we'll see. But now, I've got it in the right place, and I'd rather not use super glue, but I think that's what we're going to have to do. So I'm going to go ahead and get out the super glue gun and get this thing glued on. I'm actually quite impressed with the way this thing turned out. You know, it could have been a lot better, but I tell you what, it could be a lot worse. So now we can go ahead and check if our 3D printer's done and see if we can go ahead and start constructing our primary coil. Alright, so this turned into a 2 or 3 week project, and a lot of things had to be changed. So unfortunately, through all those iterations, I stopped videoing, but I will catch you up on what's going on. So I finally finished the 3D print for the primary coil, and I've gotten the primary coil wrapped around the 3D prints with zip ties holding it in place. So that's done. Now, our original Leyden jar capacitors did not work. There was a few explosions and some other things going on that it was pretty much trial and error, but I figured out that the plastic in the bottles was just too thin for the high voltage. And so I transferred over to a beer bottle capacitor network. The first problem with this was too much corona discharge. So all of these are filled with salt water up until about here, and then I put mineral oil to the top to prevent that some. And so this is our capacitor, our new capacitor network, which is basically the same idea as the one before, but they're made with beer bottles. And so our next upgrade was, I finally figured that I wasn't going to use the flyback transformer. It was not supplying enough voltage or current. So here we have a neon sign transformer, and this neon sign transformer is 15,000 volts. And I actually had to upgrade the wiring as well because the voltage was so high it was leaping across the wires. So I also have a line filter to prevent EMI from coming back into my power lines. So I've put that on the neon sign transformer. And this is our spark gap. It's not mounted yet, but this is the idea. It's just going to fire in between these two sparks to generate the pulse that we need. For our primary coil. So the first few power ups to this, it was awful. So eventually I added the variac transformer so we can control the voltage out to the capacitor network, because I was trying to diagnose and see what was going wrong. So the variac helped me figure out that the lane jar capacitors just weren't cutting it that I had before. So now that I have that, I can control the power of the Tesla coil. And we also needed to add a AC fan into the mix to cool down our spark gap so the air wouldn't ionize in between and form a permanent connection. So this right here will go in between the spark gap to keep it cool. And at this point, I just need a nice sunny day outside to get this thing outside and grounded and wired up. So the only thing that needs to happen is pretty much I slap the primary coil up, or secondary coil here, put the Coil oil on top, get it grounded, plug it in, and we should be ready to rock and roll. Alright, so unfortunately that's all I have for this video. I have the build. I'm not quite sure when we're going to get to power it up, but I will definitely make a video when I power it up to showcase pretty much how it works. But I really thank you guys for watching. I know this isn't like an electronics channel, it's more of a radio channel, but I thought this kind of belonged here and I thought some people would probably enjoy it. So if you haven't liked the video already, if you do like it, make sure you hit the thumbs up. Make sure you comment down below what you think, what I could have done better, and make sure you hit the subscribe button. Anyways, 73 to you.